we are going to find antiderivative for the function f of x is equal to x plus 1 times 2x minus 1. For antiderivative, this just means that we are going to do the derivative backwards. However, here we have a polynomial times another polynomial. So in this situation, it doesn't matter if you want to do the regular derivative or the derivative backwards. What we should be doing is, because this x is going to be affected by the 2x, we should multiply out everything just like do the usual for your methods. And let's do that first. So this is still going to be the original f, and we take x times 2x, that will give us 2x squared. And we take x times negative 1, that's minus x, and we continue, this is 1 times 2x, that's 2x. 2x combined with negative x, we have plus x. And lastly, positive 1 times negative 1, that will be minus 1. So in this situation, we are ready. If you want to take the derivative of this, or the antiderivative of this, you should look at this instead of the original. And let's review the regular power rule that we can use in this situation. If you want to take the regular derivative, you use the regular power rule. Let's review real quick. The regular power rule says, if you have x to the n power, what you do first is, you take the exponents, you bring it to the front, and then you subtract 1. So you take the exponents, bring to the front, this right here is step 1. And the moment you subtract 1, this is step 2. The derivative of x to the n power is n times x to the n minus 1. However, if you want to find the antiderivative, you have to use the backward power rule in this situation. So if you have an expression that's in the form of x to the n power, what you want to do is you want to reverse the order and also reverse the operations of the original. Earlier, we bring the exponent to the front first and we multiplied it, and then we subtract 1 later, right? That's a step 2. So what we want to do first for the backward derivative is that we are going to add 1 first. This right here is step 1. We want to add 1 to the exponent first. And then step 2 is we are going to look at the new exponent, and instead of multiply, we are going to divide by the new exponent. So the new exponent is n plus 1. We divide it by that, we put that in the denominator, so we divide it by n plus 1. And this part right here is step 2 for the backward power rule. So what we're saying is, if you have x to the n power, the antiderivative of x to the n power is going to be x to the n plus 1 over n plus 1. Okay? So we can apply the backward power rule in this situation right here, because we are trying to find the antiderivative, and this right here is in the form of the power functions. And I will use capital F, stands for the antiderivative for the original. So by looking at 2x squared, we are going to add 1 to the exponent. So we add 1 to the exponent. So 2 plus 1 is 3. We are going to divide it by the new exponent. So we just put divided by 3, just like that. So for the first part, we are going to have 2x to the third power over 3. For the next one, we have plus x. So this is the x to the first power. And once again, we add 1 to the exponent first. And then we look at 1 plus 1 is 2. That's a new exponent, and we divide it by the new exponent. So here, we are going to get plus x squared over 2. And for the third one, this is like minus 1. And if you do this enough time, you will know that the antiderivative for minus 1 is just going to be minus x, because the derivative of negative x will give you negative 1 right here. And you can also apply the backward power rule, because the 1 is like x to the 0 power. And we can add 1 to 0. That's why we have x to the first. And then divide it by 1. So we have x. Okay? So this right here is the function part, and we are done. You apply the backward power rule for the function part, like the power parts right here. However, whenever you are doing things backwards, you always put a plus z at the end. Because for the antiderivative, what we're trying to say is the derivative of this part will get you this. Look at, 2x to a third power over 3. If you take the regular derivative of this, you are going to end up with 2x squared, right? So is this, x squared over 2. If you take the derivative of this, you are going to end up with just x. The derivative of negative x will give you negative 1. The derivative constant is 0, but then you always include the plus c when you are going the antiderivative. Anyways, this is a real quick introduction for the antiderivative and also the backward power rule for the antiderivative. That's it.